Fieldwork exercise number 3. Area determination of polygonal field using tape. Objectives: to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. The instruments and accessories needed are range poles, measuring tape, markers such as chalk or marking pins, and plumb bobs. Letter A. Area determination by base and altitude. First, the instructor assigns the locations of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. The chief of party divides the polygon into 3 triangles, which will be designated as A1, A2, and A3. Then, 2 of the remaining students measure the base of the first triangle chosen in the polygon using tape. Then measure the length of the altitude of the first triangle. The altitude of triangle is perpendicular to the base, meaning it has 90-degree angle, and coincides the opposite vertex, which is the corner B of the polygon. We can use the 3-4-5 method, wherein we will use 3-4-5 multiples as the sides of triangle to see if it is perpendicular or not. If not, you can make adjustments. Record the length of the base and altitude on table 3.1, area determination by base and altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. For the second triangle, again, we will be measuring the length of the base and the altitude, which is perpendicular to the base and coincides the corner A. Then record the length of the base and altitude of A2. To get the area of the triangle, again, use the formula 1/2 times base times altitude. For the third triangle, again, we will measure the length of the base and the altitude, which is perpendicular to the base and coincides the opposite vertex, which is this time the corner D. Then record the length of the base and altitude of A3 on table 3.1. To get the area of the triangle, use the same formula 1/2 times the product of base and altitude. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
B. Area determination by 2 sides and an included angle. Step 1. The same field described in A, area determination by base and altitude, will be used for this method, but change the designations on the corners. Use F, G, H, I, and J instead of A, B, C, D, and E. Step 2. Divide the polygon into 3 triangles.
Name the triangles as A1, A2, and A3.
Step 3. Measure any 2 sides of the first triangle chosen and record these measurements as sides A and B. Step 4. Determine the included angle between sides A and B.
And in order to do that, we will use cosine law. We will measure and mark the same length at each side of the angle. And then we will measure the distance between these 2 points. Then we will use cosine law, which is c squared equals a squared plus b squared minus 2ab cosine theta.
And record this on table 3.2, area determination by 2 sides and an included angle.
To get the area of the triangle, multiply the product of side A, side B, and sine of the included angle to 1/2. Record the lengths as well as the angle and compute for the area.
Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon.
Again, for the second triangle, two sides will be measured and also the included angle using cosine law. And for the third triangle, any two sides will be measured again and also its included angle using cosine law. Input all the recordings from A2 to A3 and compute for the area. To compute for the area, use this formula again.
To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
We can now proceed to part C.
Area determination by Heron's formula. First, the same field described in part A, area determination by base and altitude, will be used for this method but change the designations on the corners. Example, use K, L, M, N, and O instead of A, B, C, D, and E, and F, G, H, I, and J. Next, divide the polygon into 3 triangles. Then measure all the sides of the first triangle chosen
Note that you can skip measuring the sides that were already known from the previous procedures.
and record these measurements as sides A, B, and C on table 3.3, area determination by Heron's formula. Furthermore, determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of the semi-perimeter side A, side B, and side C to equation 4, Heron's formula. And lastly, repeat steps 3 and 4 for the chosen second and third triangles of the polygon.
Measure the 3 sides of the second triangle, side A, B, and C. Determine the semi-perimeter of the second triangle by multiplying the perimeter of the triangle by 1/2. And to determine the area of the triangle, again, substitute the values of semi-perimeter, side A, side B, and side C to Heron's formula. And for the third triangle, side A, side B, and side C will be measured again. Determine the semi-perimeter of the third triangle by multiplying the perimeter of the triangle by 1/2. And again, to determine the area of the third triangle, substitute the values of the semi-perimeter, side A, side B, and side C to Heron's formula.
To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
Thank you for watching!